Hello, in this recording I'm going to discuss the first three rules for differentiation: the power rule, product rule, and quotient rule. So consider just a kind of a basic function f of x, a variable x to a power of n. The derivative of that is going to be n times x to the n minus 1. So just a really simple example might be something along the lines of x cubed has a derivative of 3x squared. And simple enough. If you have a fraction, if you have something like the square root of x, typically it is easiest to write that as a power of 1/2. And then when you take your derivative, you can bring the 1/2 down, drop that power by 1 down to negative 1/2, and you can finally write your derivative as 1/2 with the root x on the bottom, just like that. You can see that, just as a side note, this is not differentiable at 0 because it's undefined. If you drew a graph of the square root of x, it looks like that. And right at that point 0, you would have a vertical tangent, kind of going up and down like that. And the same goes for a cube root. Say you had f of x was the cube root of x, or you could call that x to the 1/3 power. The derivative there would be 1/3 x to the minus 2/3. And if you just clean that up a little bit, you could see you've got 1/3 and then the cube root of x squared on bottom, and x cannot be 0. And the graph would look something like this. And right in that middle part, right at 0, I didn't draw that good a graph, but you would see the tangent line would be vertical, and again an undefined point. It's not a differentiable point because of that vertical tangent line. So the power rule is super easy. It's something that I'm sure you can get the hang of really fast. Next is the product rule. The product rule, I'm going to use y here, and because I'm going to write f times g. I'm going to write the function as a product of two functions, f and g. And so y prime here would be f prime times g plus g prime times f. That's it. And let's just do just kind of a quick example here. Suppose you have y equals 5x squared times x cubed minus 8. I'm going to just label. It helps me to label what f is and what g is. F prime is 10x, g prime is 3x squared. And so if you put together your y prime, you get f prime times g, 10x times x cubed minus 8, and then plus g prime times f. We're going to clean this up and get y prime is 10x to the 4th minus 80x, and then plus 15x to the 4th, and that will all become 25x to the 4th minus 80x. Now, as a side note, you could have also done this particular problem as a power rule. If you had said y is going to be 5x to the 5th minus 40x squared, if I had distributed the 5x squared first, then you'd now have a power rule. Many problems work like this, where you can do them with multiple rules. So same thing. The quotient rule will be next. Say you have, I'm going to write write that down. H of x is f divided by g, and h prime is f prime times g minus g prime times f over g squared. So just follow the formula. Suppose you had h of x was sine of x over x cubed plus 2. You would need to identify that f is sine of x, g is x cubed plus 2, f prime is cosine, g prime is 3x squared from the power rule, and then you can put your pieces together and you'd get f prime g cosine times x cubed plus 2 minus g prime times f 3x squared times sine of x all over g squared. And this is not what I'm going to clean up too easily, so I'm just going to leave it like that. But just a legitimate derivative in terms of x. You can plug in x everywhere you see an x and get the derivative of h at any particular point. So that's the power rule, product rule, and quotient rule, just with some easy examples. I want to just do a couple more examples, and then we'll wrap this up. Excuse me. Let's do P is nRT over V minus V minus NB minus A N squared over V squared. This is a mess. I'm going to read the question to you. It says gas in a cylinder is maintained at a constant temperature and a constant pressure and is related to the volume by this given formula. So this is pressure. And they told us it's at a constant temperature, it's at a constant volume, and it tells me that A, B, N, and R are constants. And I'm just going to add to the list since they told me T and V were constants also. Even though this looks kind of scary, everything is a constant except for what's not a constant here. A is a constant, N is a constant, V is a constant, B is a constant. V is not a constant. I misread that. So your only variable here is V. N, B, R, T is a constant. So I'm going to just write this. Think of this as P of V is nRT over V minus NB minus AN squared. That kind of helps you identify what's a variable and what's a constant a little bit more easily. So with this in mind, I'm going to do the quotient rule here. And I'm going to actually rewrite this as V to the minus 2 with a constant coefficient and do the power rule. So I'll show you how this works out. For this beginning part, I'm going to call F nRT and G V minus NB. And because N, R, and T are constants, the derivative of all that is 0. For G prime, since V is a variable, N and B are constants, the derivative of G V minus NB is just 1. So the quotient rule here is going to work out really nice. So we'll do P prime as a function of V. It's going to be F prime times G minus G prime times F all over G squared. So that's the beginning of this example. I'm going to just take a moment and rewrite this as A N squared times V to the negative 2 power. that v to the 2 on the bottom can come up as a power of negative 2 on top. Now this is a coefficient that's just going to stay there. Negative 2 is going to come down. We have minus negative 2a n squared v to the negative 3. Drop that power by 1. So this whole thing is the correct derivative now. I just need to clean it up. P prime of v equals negative nRT over v minus mb squared. And then 2 minuses make a plus a plus 2a n squared over v cubed. So you can see that the quotient rule, or any of these rules, can be applied regardless of whether you have lots of coefficients that are numbers or even just variables which are constants. The last example of the quotient rule I want to show you is regarding trig functions. I want to consider the function tangent. And hopefully many of you already know that the derivative of tangent is secant squared. That's just a fact that you need to remember. But if you take tangent and write it as sine over cosine, you can kind of derive that the derivative here is secant squared by just identifying f is sine, g is cosine, f prime is cosine, and g prime is negative sine. And now we're going to use my quotient rule, put the pieces together, and we'll have our derivative. F prime times g cosine x times cosine x minus g prime times f, that's a negative sine, times sine, all over g squared. This is cosine squared. 2 minuses make a plus sine squared over cosine squared. And notice that cosine squared plus sine squared is a trig identity. That just is 1. So you get 1 over cosine squared, which is secant squared. So that'll wrap up the power rule, product rule, quotient rule. Thank you very much.